Okay, so I am very excited for this one because this scratches the itch, which is like anytime someone says like I had the worst like date last weekend and everyone like leans forward and is like, can you tell me everything that happened like from the start? Like what happened, right? So this is the IT equivalent of that. Like we want to hear like I always love to hear what are these breaches. This always fills up my conversations with customers of like, hey, you don't want to be this person. Let me tell you this story about something that happened. So I'm looking forward to all the horrible, gory war stories you have about what you guys have learned and some of the best practices that go with it. So take it away.
Right on. Well, thanks much for the introduction, Mark. This is Cloud Breaches, Case Studies, Best Practices, and Pitfalls. I just want to give a shout out to the organizers. I've been in a position like this before, so I know a lot of work goes into this. So thanks for putting this together. All right. Okay, so here's just an agenda of what we'll be talking about today. We'll do a quick round of intros as per usual. Then we'll take a look at the current cloud threat landscape, just kind of what we're seeing out there right now. And then we will talk about some frequent attacker methodologies. So this is obviously just going to be some interesting types of methodologies we've seen. And then we'll talk about some common weaknesses and root causes, followed by some best practices. And this is just coming from our incident response scenarios that we have, and also the strategic assessments that we do that span all cloud service providers. And lastly, we'll just end on some case studies. I'll pass it over to Chris for a quick intro first, though.
Hey guys, I'm glad to be here. My name is Christopher Romano. I'm a senior consultant with Mandiant. I have around over like 14 years of experience, both public and private sector, based out of the US. I know Dylan has an interesting thing on his slide, so I didn't really put anything besides what I'm interested in, but I just moved from Vegas. I live in West Virginia now, and I made some cured maple syrup this past winter, which was pretty cool. But my interests are, everything cloud. I love the cloud. I love learning more. Of course, DFIR. Of course, I'm a Mandiant. Dabble with a little bit of pen testing, and and then last but not least, I love architecting things from the ground up securely.
I feel kind of bad because I'm based out of Canada. I've never made maple syrup before. Just joking. That's on the, you have to do that to be a citizen. I'm a consultant at Mandiant, about 7 years security experience, but doing technical things for much longer than that. Some of my interests there, the last few years I've been focused primarily on the cloud stuff. And I'm okay at Brazilian Jiu-Jitsu, but that's probably depleted a bit since the kind of lockdown stuff started. All right, so before we get started, I do have to talk about this first. Case studies and examples are drawn from our experiences and activities working for a variety of customers and do not represent our work for any one customer or set of customers. And in many cases, facts have been changed to obscure the identity of our customers and individuals associated with our customers. So unfortunately for you, Mark, I'm sorry, but we can't kiss and tell as much as you would probably like. All right, so let's take a quick look at the current threat landscape. So where are cloud services at, essentially? Organizations across the globe have been moving data and services into the cloud at an increasing pace. Cloud service providers have invested in security features for the platforms, but unfortunately, there is a common lack of awareness of these security features within the different cloud service providers. In addition, due to this lack of awareness of either cloud service provider features for security, there is a misconfiguration of tenant settings that we commonly see as a result. So we've observed a combination of targeted and opportunistic threat actors target cloud assets. And according to Gartner, cloud is now a $186 billion market. There's been about a 21% growth of adoption within the last year and a bit. So obviously, attackers have been targeting these types of things since their inception, and will continue to do so. Here's some other statistics around cloud, this time from our own market research. I'm not going to labor these too much, but I think that the most jarring one there is that 95% of the cloud security failure is the customer's responsibility. So that's really on the shared responsibility model side. 95% of the time that there's either an issue that we encountered during an IR or that we see during a security assessment, it's going to be on the consumer side versus the service provider side. And also 11% of our IRs have a significant cloud component. So this isn't just like, hey, there's a couple of VMs in Azure subscription that are involved in this IR. It's that the attacker is actually in their cloud environment. Just need a quick water break there. So speaking of our IRs, in MTrends 2020, We have some key cloud highlights here. And in this document, if you're unaware of what it is, it's essentially an amalgamation of all of our incident response data. We boil it down to the statistics and provide different kind of trends in what we're seeing. 2020's version does feature a whole cloud case study section. It's not like a case study that we'll see here, but there's another one in there. The cool thing about the 2020 version is that you don't have to enter your email. So I'm not trying to sell anything. You can just go and read the report there. These are the main highlights. Again, I'm not going to labor these because these themes come back a lot during the talk, as you'll see. So we'll dive more deeper into each of these as we go forward. All right, so that's just a quick rundown of the current threat landscape. So let's take a look at the most frequent attacker methodologies that we see. So one of the most common things, it's been kind of covered in some of the other talks as well, is rogue devices and shadow IT. So this isn't necessarily something that an attacker does. This isn't an attacker methodology, but it's more so due to some of the lack of understanding. Even like the last talk Chris was just talking about, people will just grab their own credit card and go spin something up. You get some issues like this, right? You can't have visibility on these as the security team. And in addition, these people may misconfigure them, and that could lead to compromise. So some common things that we'll see is maybe an unpatched version of WordPress or some other application facing the internet, leading to a compromise of that environment. Or you'll see something like a remote management internet facing, so RDP or SSH facing the internet. Oh, there we go. Okay, sorry, not sure what that was about. Okay, so another thing that we see pretty commonly is credential compromise via public exposure. So in this case, we can see that we have our attacker there as noted by the smiling imp icon on the laptop. And what this attacker is going to do is kind of search for credentials. Could be in a configuration file, could be in something that has been uploaded to a public repository. So you can see that he's doing some Google dorking. He is looking at GitHub or GitLab. And once they find some credentials, what they will do is then use those credentials and enumerate the types of access they have to different cloud service providers. And this is something that we commonly see. Prevention and detection mechanisms for this, we will cover in the case study later, and as well as in our best practices section as well. Something else is a cloud platform service attacking. So I know we've moved on a little bit to being able to have web applications being built in containers and with serverless setups. However, a web application is a web application, and there still may be vulnerabilities introduced by the web application code itself. So in this case, we have the attacker again there, and he is doing some scanning on a web application. If the attacker is able to find a vulnerability that is able to spit out the credentials that are tied to that container-based web application, so something like a server-side request forgery vulnerability, he would then be able to take those credentials, and if they're configured improperly, which you'll see later on, it's pretty common, perhaps he could do something like create a function. And this function is then able to take the keys that are assigned to the container and post them to a location that the attacker has access to. So in this case, even if you're using short-lived credentials with the container, the attacker would still be able to get those credentials as they're refreshed due to his function. Once the attacker has these credentials, they're then able to continue on with their mission, do some reconnaissance. That mission is really going to depend on what the attacker is motivated by, but most commonly it's something like look for personally identifiable information. They could then exfiltrate that data. We've seen them set up publicly accessible storage, so some sort of object storage in your cloud service provider, and then just collect the data from there afterwards. All right, another one that we've seen is hybrid cloud lateral movement via cloud app. So say that 5 times fast. In this case, we have the attacker here, and he has created a document that he's uploading to some sort of cloud-based application, so some sort of SaaS application. And once the evil document has been uploaded, it's downloaded in step 2 there by the individual employee within your organization. As part of their job function, they'll go and open that. And then what will happen is, due to the malware embedded in the document, it will beacon back to the attacker's infrastructure. And then from there, the attacker is able to do things like download more malware, or you can see in step 4, we have exfiltrating data. Just something to note here is that this doesn't have to just be data that they're interested in as part of their motivations, but this could even be something like credentials on disk. So in your AWS credentials file, they could potentially pull that down, and then back to like the public exposure, they could then enumerate what sort of access they have, and then use those from there. Okay, another attack that is getting increasingly common is an attacker in this case is doing some reconnaissance on your organization. You happen to be an application developer. They find out that you're using a specific third-party library or package. And then once that reconnaissance is done, they then go and target that developer who makes the package or library that you use. Their objective then is to gain access into that developer's account. So they're able to publish a version of the repository, or sorry, publish a version of the package or library that they've created with some suspicious or malicious components into the repository that is used to host this. Once that's in there, you can see in step 3, as part of your normal application pipeline, your application would then pull down the library as per usual, right? Nothing's changed. The version's changed. In most cases, they're configured to automatically grab the latest version anyways. We don't really see version pinning that much. And then it would be built into your application. Once that happens, it just gets deployed into your environment like normal. However, in this case, as we can see in step 4, the attacker is then able to carry out some sort of malicious action based on what they wanted to do. So we've seen cases where attackers will grab cryptocurrency wallets, credentials, whatever they might be into. And obviously, we're just scratching the surface. There are many more. Some common ones that you'll see, I'm sure you've read the news before, you probably have seen there's ones with data stores without access controls. So things like open S3 buckets, credential compromise just through normal means of infection. So something like phishing. Then also third-party applications. So we've seen instances where phishing, instead of having a link that just tries to grab credentials or malware that just tries to grab credentials, it'll actually ask the user to approve an OAuth application to be used by the organization. And then once done, the attacker can use that to gain access to the account. In addition, we've also seen cases where, although this is far and few between, but we've seen cases where malicious applications downloaded from like the Google Play Store or something have aided in attacks based in cloud services. All right, so now that we have an idea of some frequent attacker methodologies, let's take a look at some root causes and common observations. Again, these are things based on the security assessment services that we do in our incident response scenarios as well. So Chris will take the lead here in a second and talk about the different actual cloud service providers, the different issues that we see in those. But here's just some common root causes, kind of agnostic of any of the cloud service providers. The first one that's pretty common is insufficient protections of critical assets. And what this really boils down to in most cases is organizations don't really have a great understanding of what is a critical asset in their organization. I know we just talked about things like CMDBs and things like that, but without having really done a crown jewel assessment, 2 servers in a CMDB might be a crown jewel, or they might be a critical asset according to those teams each, right? So without that understanding, it's hard to apply proper protections to what the critical assets and where those critical assets actually are. Something else we see pretty common is insufficient incident detection and response. And this is more about how either cloud log sources are not included in the SIMs, there is no cloud use case or alerts, and playbooks or incident response plans don't really include any sort of cloud components. So this could be even the team not really understanding maybe how to take an image of an EC2 instance or something similar to that nature. Something else that Chris will touch upon quite a bit is poor identity and access management or privilege management. So this really boils down to loose permissions, or it could even be something like lack of MFA on accounts. And then finally, lack of understanding about the environment. So this could just be something like either the security teams aren't really aware of the different security features within the cloud platforms, or security teams don't communicate with operations teams or DevOps teams or any really other technical teams to understand what services are being used and how they're being used as well. So these are some pretty common root causes that we see across the board. I'm going to hand it over to Chris now to talk about O365 in Azure.
Thanks, Dylan. Yeah, so I'm just going to go over a couple of observations we see mainly on our incident responses, and as Dylan mentioned in the beginning, like our cloud security assessments that we perform for many organizations across the board. So these are, you'll notice as we get into the next slide, is that these are pretty fundamental across the board, but a lot of our clients still are not preventing usage of these, like especially like the first one, legacy authentication protocols. We respond to multiple incidents a year where this is still enabled in a client's environment, and the attacker does leverage these legacy authentication protocols like POP, IMAP, MAPI, ActiveSync especially, to bypass a multi-factor solution in place. With that, definitely a recommendation there would be from us would just, of course, disable that across the board using either your conditional access policies, or just disabling a period within your O365 admin console. As Dylan mentioned too, from the root causes, this is pretty standard. This is pretty fundamental to security though. But surprisingly, we're still seeing this, especially on IRs and with our assessments, as I mentioned, but not using multi-factor. Azure came a long way. They are implementing conditional access policies where you can enforce this for all users within your environment. Definitely you want to leverage those. Because attackers, they tend to focus on brute forcing, and they love doing password spraying attacks. The next one we got is the two remote PowerShell typically enabled for all users. A lot of organizations don't realize this, but remote PowerShell is enabled for all users, especially O365 users. With that said, we tend to see on our IR engagements that attackers will automate extraction of data from users' accounts using PowerShell because it goes unnoticed. They're not really monitoring for it. With this, with every standard user with O365, this should be disabled. The only correct usage for this would be for your administrators of the tenant. So definitely want to disable that. The next thing too is privilege access workstations are really used. So you don't have that hardened jump host to access your environment. We tend to see that attackers love to target your administrators within the environment. Whether that's phishing or delivering drive-by malicious documents to them. With that said, you should implement pods within your environment. Harden with the GPOs. Restricted web access to only to your tenant, whether it be a proxy or firewall. The next thing too, Dylan touched a little bit about this, but we see a lot of misuse of administrative credentials. So whether that's your developer setting up their own account and exporting production data to their own account to do further development work, and not seeing any of that within your environment. We see backdoors being set up constantly. Like Dylan mentioned, rogue IT assets. So not having that monitoring capability is definitely a significant factor there. The next one that we see is minimal control access to services, or not even knowing what a service does. Microsoft comes out with different features all the time, and they even publish that with whether in Azure or within O365. This goes back to that that third-party app access. Like we respond to incidents where the administrators does not approving those third-party app accesses, then that third-party app it tends to be malicious. It gathers the user's OAuth token or sensitive credentials from their O365 environment. The attacker is able to leverage that and then basically extract data from the environment. Next one we typically see is poor hygiene for cloud network configurations. So with this goes with multiple things. So management ports exposed to the internet, that's a big factor. We see that across a lot of cloud environments. Another thing too is that we see clients actually putting development resources within the same virtual networks as their production resources. With that said, then they usually give their developers a little bit more access to their development resources, in order to develop. Attackers end up compromising that, pivoting to the production resources, and those production resources have access to all of their PII databases, etc. The next one too is, as Dylan mentioned, current security detection and response and lack of log monitoring and threat hunting. Many of the clients don't know how to set it up. They don't know where to start, especially with the cloud, or they don't know about the advanced logging features that they can enable, especially like the granular logging features that could see, query access within, your SQL databases within the cloud, or your storage accounts. All right. The next thing we're going to talk about is the top observation for AWS that we see across whether IRs or like as we mentioned, cloud assessments. So one thing to note, AWS, you're going to see kind of a key trend here across all of our cloud providers. You can see this fundamental concept that we're still seeing it out here. So notoriously, AWS managed policies we see are notoriously overly permissive. Even AWS recommends it within their documentation to restrict some of their managed policies in place, or they tend to say that you should use this policy to set up your environment and then restrict it further. We try to stay away from them as much as possible. Try to develop those customized roles. Follow that principle of least privilege. The next factor I really want to hit here is, IAM policies giving wildcard access to resources. As you can see in the news all the time, especially with the recent release. I know everybody's talking about the Capital One incident, but as that mentioned, overly permissive policies can give you the result of that. Can't really go further into that, but the next step would the next thing I really want to hit is permission boundaries and service control policies not being used. So not a lot of people are using that that enforcement from the top down for your service control policies and restricting access across all of your accounts. We see that still out there. Service control policies should be like your GPOs and your Active Directory. You can spread that across all of your accounts and know that enforcement's in place and putting those correct guardrails in place. The next thing, lacking, these two are kind of combined. Stay away from long creds as much as possible. Use IAM roles, leverage creds, leverage temporary creds as much as possible. Those long-lived credentials, those are like represent significant risk. And if you do have to use them, definitely establish that baseline for usage and to determine the anomalous traffic outside of that baseline. All right. The next thing, so this is, as I say, you can see a key trend. So I'm going to go through, the first one because this, as you see, you can see it across the board. But another thing too we see is shared SSH keys across EC2 instances. From a management perspective, this is easy. It will assign one key pair to to your application, but what do we do with those key pairs? What do we do with those credentials? We see this being misused. Clients are not really storing them in a PAM solution. So the developers have local SSH keys on their workstations, or they're not leveraging Session Manager to manage their EC2 instances properly. The attacker ends up sending a phishing email, is able to pull those SSH key pairs, and then it's able to pivot to the environment, and that SSH key pair is used across all of those instances within their environment. They're able to extract data and compromise the account further. Another key thing I want to hit on here is that the abuse of AWS services and attached roles. What this said is that be cautious of what you grant IAM roles to your AWS services and who has access to use those services. We're going to see Lambda used a lot, especially whether it's an insider threat or by an attacker, just because it goes underneath the radar. So with this said, if you say you sign a Lambda IAM role that has administrator rights to it, and your developer has only read-only access and he's able to execute Lambda functions, he's able to pass the role to the service, then he's able to do basically whatever he wants with that Lambda function. So just be careful and be cautious of what permissions you're assigning to those roles and who has access to them. The next thing, so there's no control over services or regions. What this means is that attackers love to tend to focus on unused regions within your account, and just because of the aspect that you don't have that correct security monitoring in place, you don't have those security controls in place, you don't have those guardrails in place, and you're not monitoring. That's the huge factor there. We see a lot of attackers, they have it to a point where they're automating their crypto mining rigs. Basically, as fast as CloudFormation can deploy, they have templates ready. They have IAM scripts ready to basically set up their entire environment to start Bitcoin mining as quickly as possible. And this could be in an unused region. We had a case where client had a hefty bill of $1 million, within a 3-day period, and it went undetected. So, of course, AWS will notify you of that now, but this is, previous past case, but it still takes delayed notification of that from AWS. I've already talked about permit users to pass any role to a given service. That's a huge one, especially to like EC2 and Lambda, because that's definitely a privilege escalation route. The last ones, watch what excuse me. So no monitoring and security tools. Attackers tend to, we tend to see, no integration into security detection and response. As I mentioned, this is like the Azure one, where clients are not really implementing that across the cloud. So when we respond to incidents, they don't have the sufficient detection mechanisms in place, or they're not aware of advanced logging features. This is huge in AWS, especially with S3. Like object level logging on S3 buckets is able to determine, what objects are actually accessed within the bucket. So if we respond to an incident, use your third-party console access. Hey, what objects were accessed in this bucket, so we can notify the correct personnel. Without this enabled, we can't definitively say which objects were accessed, and we got to determine either by billing reports or what type of CloudTrail logs are provided available in order to determine that.
Sorry, I'm trying to click through the internet and it's having some troubles.
Okay, yeah, no problem. I see there's a little bit of delay there.
Uh-oh. Okay.
All right, we're gonna hit on some top GCP observations. So service accounts being used for daily tasks, and this comes down to the permission standpoint, like assigning specific users, like the service account token creator permission, or the service account user permission to manage multiple service accounts. We see this abused a lot, especially by insiders to do whether they're trying to circumvent regular security controls, or even if their credentials are compromised, that's something to go under the radar, is to leverage the service account. Overpermission by roles. This actually goes back to what Dylan said. We see this a lot across the board. Having that act as or impersonate service account permissions add to the account. You definitely want to restrict those where you can, and practice the principle of least privilege. Another thing too is that we see is the lack of structure of governance over projects. So, say improper IAM policy science, like the organizational levels as trickled down, that are inherited at the lower project levels and lower project resources. We see that all the time, just because of the organization not understanding of what is in place and how that inheritance works within their organizational structure of their GCP account. The next one goes into lack of rotating user credentials. I've already mentioned this, but this is critical. Treat your service account keys as your passwords. Rotate them as much as possible, or ensure that you know where they're being used at and how you're going to be able to rotate those in case of a compromise. That's critical. We've responded to multiple incidents where we go into the organization and we say, hey, this key is compromised, and they're afraid to rotate those credentials just due to the fact that they don't know what it's going to break and what it's going to cause, what kind of outages it's going to impact across their account, basically. So.
Hey, I'm sorry, but the click through doesn't seem to be working there. I'm getting a different cursor.
Okay, there we go.
Oh, cool.
Yep. All right, so the next one, as I said, you're going to see a lot of things across the board here in the CSPs, but and this is what we tend to recommend too, especially in our assessments. But definitely have those bastion hosts set up and there's jumped hosts into your cloud environments, and then ensure that those are hardened. You have your proper security monitoring. It's a centralized place where your security team can review who is going in and out of your environment, and what is being deployed from those instances or virtual machines. Misconfigure IAM policies that permit privilege escalation. This is big, especially with Google, because it tends to be primitive roles tend to be used all the time, and within those primitive roles, you have those certain actions that will be able a user will be able to privilege escalate, especially those service account actions that I mentioned before. The next thing is fundamentally, lack of MFA enforcement. We still see that. And then super administrator accounts, surprisingly, we still see them being used actively. This is like any administrator account, especially even for AWS. I know AWS made great strides, and so did GCP made great strides to basically um, have it to the fact where you can grant those granular permissions. I know GCP is still lacking that kind of, because even with their network infrastructure, they're still deploying primitive roles like the editor role to some resources across the environment, but they are definitely getting there. All right, the next thing too is we're not seeing any. We're seeing some across our assessment in IRs is that clients are not really leveraging their cloud, their native tools within GCP. This is definitely going to be beneficial. You can have the quick wins and see how you're observing. Quickly see what's going on in your environment. The next thing too is storage buckets with unrestricted permissions. This has to go back to IAM and how you're assigning those permissions to your IAM users. The last three, besides the lack of knowledge, but this is the same thing. They're not. We're seeing clients still not integrating the current detection and response capabilities as they do as they have on-prem, and the lack of log and monitoring, and that a lot of clients don't even know that audit logs exist for storage buckets and SQL within GCP. And then, as Dylan mentioned before, the lack of knowledge, even for the advanced logging and for the environment period is still behind. So we're just going to go a little bit about the best practices. I've already mentioned a lot of these, but I just want to hit on some key points. Require a multi-factor for CLI and console. That's just standard, standard security practice, standard security hygiene right there. Use principle of least privilege. Use temporary credentials when possible. Don't use those long-lived. Try to stay away from right from the application inception. Implement those account guardrails. It's not just a detection game anymore. It's more of a prevention as you scale out your cloud. Leverage the internal tools like Azure policy, organizational policies for GCP, and your service control policies. That definitely come in handy. Definitely, especially from a security mindset, that you can have those guardrails from the top, bottom, and you're protecting yourself. And of course, disable those legacy authentication protocols as they can bypass MFA. That's a huge factor we see, and a huge thing we're seeing across a lot of our IRs is that. So definitely want to disable. I haven't really hit on backups and disaster recovery, but the cloud still has issues. I know Route 53 went down like a couple months ago, so you definitely want to design those resilient solutions and ensure they're in multi-regions, multi-accounts. All right, so as I said, I'm going to go through all these because I've mentioned it. I kind of went through them. So a huge one, I know Dylan said I was going to mention this later on, but prevent creds from being pushed to your GitHub repos or your code repositories, by leveraging webhooks or other alternative methods. I know GitHub just came out with for private repos. You're able to scan for credentials now, which is awesome for their enterprise solution. That is definitely a great improvement on their part. Another thing that we really haven't hit on with the last three, so scan your IAC, so infrastructure as code templates for misconfigurations and for credential usage. So static credentials being used, like your RDS or your SQL database credentials being used within there. We tend to see that being pushed up, and then attackers, getting those templates, and then they're able to access that data from outside the environment. Rotate access keys and monitor them heavily if you're using long-lived. Encrypt your data in the cloud, because your CSP is not going to protect it. It's your data. It's the organization's data. So, and then educate yourselves on logging features and security features. Build out those alerts, and test them. That's one thing I would definitely encourage. And then summary key takeaway from here. So, IAM is your new perimeter. Definitely have that robust solution in place. Because IAM is everything in the cloud. As I mentioned, it's not just a detection game anymore. It is prevention now too. So you start thinking about prevention actions that you could take, to protect your accounts. Last but not least, educate. That's what I'll say. definitely want to ensure that your cloud administrators and your security personnel, they're up with training. They're ensuring that they're up with the newest security features that are being deployed across your CSPs. That way you can implement them and make sure that they're set up properly in case that investigation takes place. And now we're going to move into the case studies. So, all right, this is kind of a similar scenario as we're dealing with the whole COVID-19 outbreak and everything. But this is just one case study that we come across. So, to start off, Mr. Orange gets fired. Before Mr. Orange gets fired, he downloads some configuration information and network diagrams. Day 2, Mr. Orange is no longer with the organization. Authorization attempts, against specific public-facing systems from a single IP address, and then successful login to CI server. So basically, Mr. Orange is trying to log back into the environment. The opportunity prevention here, access was not terminated immediately once he got fired. Sensitive storage was accessed outside of working hours, so he did access out of working hours. So we definitely want to develop alerts for that. And then prevention, unknown interfacing systems without strong authentication. You definitely don't want to be putting your CI server on the internet. If you do, you definitely want to be restricting that to a trusted IP or subnet. Then for detection, anomalous amount of activity, API activity, and anomalous amount of API calls. So, and then of course the new IP logging into the CI system. So that should be detected too. You should have that trusted IP source, IP list. All right, we're gonna go to day 3. So, as Mr. Orange was in the environment, he wanted to create persistence. So he did create a user on the CI server. He actually did run some recon tools against the subnets. He did find some additional credentials and some files on a critical server. And then he did access, he did access servers housing their work, and he proceeded to perform destructive actions. So he basically destroyed all the databases that he was working on in his projects that were related to him. Here's the opportunity detection for this one. So the user was created on the CI server. The recon tool was downloaded and executed. And sensitive files were accessed, so you don't have that FIM solution in place. And then, sensitive information was accessed and deleted. And then database logging and alert, for human access on production databases. So definitely should be establishing detection mechanisms around that.
All right, thanks, Chris. That was quite the marathon. I realize we're coming up on time, so I'm going to try and squeeze this in. But essentially, we have 2 organizations here. We have ACME and ACMO. In this case, both had public-facing database instances that definitely should not have been public. They also have another commonality. Attackers found their database. They have another commonality. Attackers accessed the database. And finally, attackers asked for some money for their databases. But before that, outside of their commonalities, how did it get this way? Well, in both cases, security scanning in the infrastructure as code platforms pipelines were not able to prevent this from occurring by looking for security groups that were open to the internet. Any cloud service provider logs, such as CloudTrail logs, were not able to, were not set up to tell us that a security group was made with public access. Permissions on the developers' accounts, they could create security groups. Security teams were not involved with the application design, so maybe the developers were unsure of how to make something that they wanted to do without putting it on the internet. And then lastly, the big thing that could have prevented a lot of this as well is the relaxed database permissions, right? The weak authentication that the attackers were able to use in order to provide their databases with a facelift. So this is really how this could have been prevented within each of these organizations. These 2 organizations have some more commonalities as well. Since the deed has been done, the attacker got what they wanted, or at least hoped to get what they wanted. How did the 2 organizations notice? More commonalities. Unfortunately, they both just really noticed when their databases weren't working as expected. Obviously, this is not ideal. So how could these organizations have sounded some alarm bells? Some opportunities for detection that they both have in common here. So some rules related to automated enforcement of policies. So something like an Azure policy or an AWS config. Cloud service provider native tools, such as maybe like a trusted advisor or open source security tools like SecurityMonkey that are doing this continuous validation and scanning that things are the way that they should be. And if they're not, they can send you an alert to maybe like a Slack channel or an email. Something else could be like an IDS, so something like a guard duty or Azure Sentinel, or even database logs if you're monitoring those for detection of anomalous activities or known bad connections to the database. So it could be something like enriched with threat intelligence, so that's why it's known bad. Or even if you're just looking for anomalies, hey, this region or perhaps this IP address has not connected to this database before. And then lastly, another opportunity for detection here for organizations would be that these database logs could monitor for sensitive commands in production, such as drop. Hopefully that doesn't happen too often in your production environments. So we've covered how they could have prevented. We've covered how they could have detected. So far, pretty similar. They're in similar spots. But let's look at how our organizations responded to this. What's the differences there? Well, Acme had some snapshots. ACMO had some snapshots as well. So they're able to restore from those from a known good state. We can see that Acme rated green. So they had some CSP logs available. The cloud service provider logs were being forwarded somewhere else after they were generated. However, ACMO's side not configured properly. So limited information was available there. Database logs, yep, Acme had them. They're all forwarded somewhere else, all configured properly. ACMO, on the other hand, not really configured properly at all. Almost no information available just due to the way that they were configured. They were able to tell that their database daemon started up, and that was about it, unfortunately. Lastly, another source of information, network logs, so some sort of NetFlow logs. Acme, yep, totally had those. Those were being forwarded somewhere else. We were able to determine some information from that. However, on the ACMO side, none at all, none available. Okay, so, let's do that. Okay, so what could each org tell? What was really the difference there? Well, Acme, they're able to confirm that data was downloaded by the attacker and how much. This is a combination of the database, network, cloud service provider logs. They're able to confirm when the ransom database was created from the database logs. They're able to confirm what account in the database was compromised, again, from the database logs there. And they're able to confirm that no other activity from the IPs, so the IPs that logged into the databases, was found. So essentially they could say, hey, no, this IP that did this bad thing is nowhere else in the cloud service provider or network logs. So they went primarily for the database. And also due to this information, Acme was able to restore from a clean backup hours outside of that timeline. So this information allowed them to put a correct scope together. ACMO, on the other hand, they could tell their database went missing, and that's really about it. They were able to restore from a much earlier backup, but perhaps the potential impact here could have been reduced if they had more information in order to collect a proper scope. So as I mentioned, they didn't really have much in common for response prevention and detection. Yeah, they did. Response, not so much. So to summarize, how to be an Acme and not an ACMO, ensure that your resources are being centrally logged. Ensure that alerting exists within the cloud and that teams kind of know what to do with it. Alerting is all good and stuff, but if the teams don't really know how to do it, then what good is it really? And in order to help do this, I kind of mentioned at the end there, practice, practice, practice. You could do things like tabletop exercises. You could set up lab environments. So if you use tools like CloudFormation or Terraform, you could easily have something set up and running for you to play around with in a while to understand how these things kind of work. So key takeaways here for the response. The database logs really helped investigate who did what. The cloud service provider logs helped Acme see what happened recently. Logs for the security services baked into the cloud service provider can give some additional context or information about what else might have happened around that time frame. And then lastly, the network flow logging helped to see what connections were made and how much information was actually taken, and if information was taken. And so with that, those case studies, the that will be all from Chris and myself. So we'll open it up to questions. Chris, do you have any questions?
Sure. I'm not sure if Shaq's able to connect, but there's a couple questions here in the chat. I'll jump in. I'm not sure while Shaq's getting connected there. On supply chain attacks, manual inspection is not sustainable over the long term. What are people doing to automatically check for extra functionality in third-party open source software?
Sure. So there are some tools that can do this automatically, that can check for like known vulnerabilities within versions. There's some IAST tools that will do this, that you can bake into the pipeline, or that they can tell what's being used within the applications itself. So that is the way that we most commonly recommend, is build that scanning out into the pipeline as it's happening. But before you onboard it, definitely at least doing some vetting of the libraries and the packages is a good way to do that. But yeah, that is true. As stuff goes on, you can't look at every single version of every library or package that's being imported.
Yeah, you can't do like the clean source, OEM disk that's like off to the side, right? Yeah, kind of. Okay, great. Next question. A lot of categories, lack of MFA, lack of hardening, overly permissive, etc., seems to be common security hygiene stuff. Is the root cause lack of skilled personnel or awareness, or what is driving the hygiene stuff that have been learned in the traditional on-prem settings and now organizations are relearning? I am very excited to hear what you think it is, because I have an idea too.
So I'll take this, Dylan, and then you can chime in afterwards. So what we typically see, especially on our assessments, is that it's a lack of education, to be honest, from how to use a specific resource within the cloud, and especially from a security perspective. Security teams are still learning how to protect and how to enable, like I mentioned, those advanced features. From a logging perspective. But the typical hygiene is just they're not, like I said, it's a lack of education because they're not aware. Especially like the scenario where I use, and Dylan brought it up, but the third-party app where it's able to, where it's a trusted third-party app from O365, and it's not being approved by administrators, it's not going through that vetting process, and that third-party app is able to, retrieve the OAuth token from O365, and then attackers are able to leverage that. I don't know if you want to add anything else to that, Dylan, or.
Yeah, maybe just like one thing to add there. You're right on the fact that it is definitely lack of awareness. I was talking to somebody 2 weeks ago that thought if they deployed something in the cloud, then they didn't have to worry about security. And I know that's such a trope, but I literally had a conversation with somebody about that, right? So there is that lack of awareness, but also I think that at the rate these things are changing, a lot of people might have learned it, but maybe not keeping up to date, or also the ability for these teams now, like operations teams and technical teams, to kind of continue using these services, consuming them, building out different solutions without having any sort of security involvement or oversight. In a lot of cases too, it's not so much that the security team doesn't know that whatever thing is bad, not using this control is bad, or that this role is bad, but it's the lack of integration with these teams that are actually doing the work in building these solutions. That is what causes most of the problems, I would say.
Yeah, just to piggyback on what Dylan said. So even with like logging perspective, because traditional on-prem, you're ingesting like terabytes of logs. Now when you move to the cloud, like I know I was listening to Chris talk, and he said he had over 80 accounts. That has to be roughly around like petabytes of information, or close to it, or a lot of I would say definitely over 20 terabytes of information. We see a lot of organizations moving to big data solutions to analyze their logs. So like Jupyter Notebooks, that's like one that we've seen commonly used. I know a lot of clients are using Splunk too, but that can be really expensive. But that's another thing. I just wanted to throw that in there as well.
Yeah, I mean, I think I agree with like a lot of it is lack of knowledge, but I think a lot of it also is people spend a lot of time just trying to get it perfect before starting on deployment. I think the MFA one is a good example, and until there's like something bad happens. So I'll be on these customer conversations, and we talk about every weirdo MFA scenario. Like, well, what if the person like got a new phone And then like they got on a plane immediately, and while they were registering their new phone, like the Wi-Fi, it's like, I don't know, like they just can't get mail for like a couple hours. Is that okay? Like we spent all this time on these really obscure scenarios, and like 9 months melt away, and then something bad happens, and guess what? Everyone's getting MFA Monday morning, 8 a.m., no exceptions, rolled out.
Yep.
Like we could have just did that and like been dealing with these weirder scenarios as we went, but instead we spend like all this time trying to get it like just perfect before we start. So that's what I see a lot. Okay,
Yeah,
speed is definitely a factor.
Yeah, user experience.
Just about time.
We see that all the time.
Oh, go ahead.
Oh no, I was just gonna say, yeah, user experience is definitely a key role. What you said, Mark, is, you know, they're always worried about the user experience and who's gonna, you know, I guess gripe at them if they're MFA and they have to do some form of, you know, difficulty of entering a number and stuff. So.
Yep. So there's 2 other questions. So I'm going to take these and I will paste them into the Slack room. And
cool.
It's about logs and some documentation stuff. So there's some good stuff there. So I think we're on a break now until 3:20. So please do the survey. Awesome session. I know you guys couldn't like actually give names, but good stories nonetheless in terms of that I will definitely use to talk to my customers and kind of get them to hopefully do the right thing and be Acme and not ACMO. But, thanks so much. Great session, guys.
Cool. Thank you.
Thank you.